Question number 10 says the determinant of the matrix 6, 2v minus 5 minus v is 24. Calculate the value of v. Well, let's call this A. The determinant of A is 6 times minus v minus 2v times minus 5, and this is equal to 24. So this is minus 6v plus 10v is equal to 24. So this is 4v is equal to 24. Divide both sides by 4, and we get v is equal to 6. Now we're told that the matrices L and M are defined as follows. L is that evaluate each of the following. The matrix LM. So LM 9, 5, 3, 2. M 2 minus 4. If we multiply a 2 by 2 by a 2 by 1, we're going to end up with another 2 by 1. So row by column is only one column. 9 times 2 is 18. 5 times minus 4 is minus 20. 3 times 2 is 6. 2 times minus 4 is minus 8. Our final answer here is minus 2, or if I want, I could say minus 2. I didn't have to. Moving on. L inverse, we need to evaluate L inverse. Well, L inverse is equal to 1 over the determinant of L times adjoint L. That's L inverse. So the determinant of L, all right, first of all, L is the matrix 9, 5, 3, 2. 9, 5, 3, 2. And so the determinant of L would be 9 times 2 minus 5 times 3. This is 18 minus 15. This is 3. And so L inverse is 1 over 3 adjoint L. We're going to interchange the 9 and the 2. So it's 2 goes up here, 9 comes down here. The 5 and the 3 stay where they are, but their signs change to negative. And so L inverse is 2 over 3 minus 5 over 3 minus 3 over 3, 9 over 3. L inverse is 2/3 minus 5 over 3 minus 1, 3. That is L inverse. C, now we're down to C. Here's what we're told. We're told that PQ is the vector, column vector 5 minus 4. If P is minus 2, 3, determine the coordinates of Q. So first of all, the position vector OP is minus 2, 3. Now, a position vector is a vector that is tied to the origin. Now, if the point P is minus 2, 3, the position vector OP is minus 2, 3. the position vector and the coordinates have the same value. That said, therefore, if I want to determine the coordinates of Q, I need to find the position vector OQ, because the position vector and the coordinates have the same value. Now, OQ would be equal to OP plus PQ. So this would be OP, which is minus 2, 3, plus PQ, 5, 5 minus 4. And so this is minus 2 plus 5, 3 plus minus 4. And OQ is the vector 3 minus 1. 3 plus minus 4 is minus 1. Therefore, Q is the point 3 minus 1. Q is the point 3 minus 1. OQ is the position vector of Q, and the position vector and the coordinates have the same value. D, which I'm guessing is the end of the question, or is the last part of the question, should be. But it has 3 parts, but it's the last part of the question. D, in the pentagon OABCD, OA is parallel to DC, OA is parallel to DC, AB is parallel to OD, OD is equal to 2 times AB. Since AB is B, this would be 2B. OA is A, and OAB is B. Now, find in terms of A and B in its simplest form, AD. AD. Now, AD would be equal to AO plus OD. Now, AO is minus OA plus OD. So this is minus A plus OD, which is 2B. Put in the 2B first, 2B minus A. So this vector here is 2B minus A. Next, we need BC. Okay, BC, that's with this vector here. Well, BC, one of the things we could do, we don't have to, it's 2 marks. We could first find BD, but we don't have to, because BC is actually equal to polygon law of vectors, BA plus AB plus, oh, here we have a problem now, because I don't know DC. Do I know DC? I don't know DC. All I know is that it's parallel to A. Oh yeah, OA is 2 times DC. So this is a half A. OA is 2 times DC. So if OA is A, DC is what? A half of A. Because OA is 2 times DC. Plus DC. And that gives me 8 BC. Notice I started with B, and I ended with C. This is called the polygon law of vectors. So this is actually minus B, because AB is B, so BA is minus B, plus AD, which is 2B minus A, plus DC, which is a half A. So this becomes B minus A plus a half A is minus a half A. This is the same as saying 2B over 2 minus A over 2. This is equal to 2B minus A over 2. Or we could say a half 2B minus A. The last thing, we're asked to state the conclusion about AD and BC. First of all, AD is 2B minus A. And BC was just found to be a half of 2B minus A. So state the conclusion about the magnitude of AD and the magnitude of BC. Well, that can be drawn from your responses in I and II. Well, the magnitude of AD is equal to 2 times the magnitude of BC. You can see BC is actually 2 times, BD is actually 2 times BC, or BC is a half of BD. Now, therefore, the magnitude of AD is 2 times the magnitude of BC.